So this is the third part of the image crawler case study that demonstrates the use of Java object-oriented features. And this is going to actually walk through the ImageCounter case study source code in my IntelliJ project. As usual, you can find that in my modern Java GitHub repository in the CS folder in the ImageCounter project. So here we are in the ImageCounter project. Let's open the ImageCounter file. This is where all the magic happens for the most part. You can see here that we're going to use object-oriented features to count the number of images that are reachable from a recursively defined folder structure that can either reside locally in the file system or remotely in the web somewhere. So here's the unique URIs field we talked about before. We make that a hash set because we're running in a single-threaded program. We don't have to worry about locking. The next thing we do is we parse the arguments that are passed in, if any, and we can do things like turn on debugging. We can set the maximum depth that we want to use, and so on and so forth. And then we go ahead and create a new image counter. And here's the image counter constructor. As you can see, it gets the root URI to parse, which again is either local on the file system or remote. And then we're going to start the traversal. Just for kicks, let's go look over here at get root URI. And you'll see that we're going to differentiate between local versus remote access. And these are fields that we set that are going to keep track of where we want to look for things. So here's the root URL if we're looking with web crawling, if we're doing our crawling with a web crawler. And this is going to look at a folder in my website at Vanderbilt. And otherwise, if we're going to be going locally, then we're going to use this path URI, which is just something that's located in the resources folder. If you take a look over here in resources, you can see that I've got various HTML files like this, and I've also got images like this, and so on. And these are the contents that are used for local crawling. Popping back up a couple of levels here, back to our program, you can see that we then call the count images method, which will recursively traverse whatever folder structure we're going to be crawling. As you can see here, the very first thing we do is check to see if the depth exceeds the max depth. If it does, we print out a diagnostic, and then we return 0 because we don't want to go any further. After that, we check to see if we've already visited this URI before. If we have, we print that diagnostic, and then we return 0 to say we're done. And then finally, if we haven't seen this URI before and we haven't exceeded the depth, we're now going to call the count images impl method, passing in the page URI and the depth. And here's what it looks like. We're going to start off by getting the start page. So here's what that does. That's going to go ahead and call into the JSuper class, which is this wrapper that hides whether we're doing things locally or remotely. And you can see here the get page method is going to check to see if we're local. If we're going to be local, then we're going to go ahead and get the contents of the resources to traverse from the local file system using the resources folder, which is what stores the results. And so we go ahead and get the initial URI for this. And then we go ahead and tell JSoup, we want to parse this file. And so we turn that into a function. We do some magic here to abstract away from nonsensical checked exceptions with Java, which are annoying. And then we go ahead and we start the process here by getting the page from the file system. That's what we do if things are local. If things are remote, in contrast, we go ahead and we use the connect method on JSoup, take the URL that's passed in, and then go ahead and open that particular URL, which we do by applying this function. And that will then give us the contents of the page that we got remotely. So those are the ways we do the traversal to get the page, either locally or remotely. After we've got the page, we're going to count the unique images. We do that by getting the number of images on the page at this point. And you can see all we do there is just use the JSoup select method on the document page in order to get all the images. So it gets us back an elements collection of images, which we then pass to count unique images. Count unique images first calls the Java replaceAll method, which applies a regular expression to concisely remove the index.html or /index.html suffix from the page URI. A slash is then appended to a non-empty page URI, thereby ensuring that duplicates are handled properly for both local file system traversals and remote web-based traversals. And then we iterate through these images. And for each of these, we take the page URI as the prefix, and then we add the image source part, which gives us the URI. And then we check to see if we've seen it before. If we have not seen it before, we increment the count. Otherwise, we print out an error message and we return the final unique count. At this point, now we've got the number of images on the page. We're now going to go and recursively crawl to find the images that are reachable from this page. This, as we saw before, uses a page select operation from JSoup, getting all the hrefs that are on a page. For each of those hrefs, we're going to call count images recursively. So that's going to take us back to kind of where we started before, with each new URI being its own root. We're kind of rooting it at a new level. And for each of these links, we're going to call this JSuperWrapper method. And you can see what we do here is if it's local, we're going to get the href. And if it's not local, we're going to get the abs href, which will make the call across the network. Again, unfortunately, JSoup doesn't do this for us, so we have to write a little wrapper class to hide that difference. We're going to take the results of count images for each of these links and then add them to the running image count, and we'll return a count of the total number of images reachable from this page at the bottom of this method. And then you can see what we've got here is the number of images in links on the page that are reachable. And the final thing we do is we add those values together. So number of images in the page and the number of images that are reachable from this page. So that's pretty much it. Let's now go ahead and run the program. You'll see that what it's going to do is it's going to start up, and by default, it's running using things that are local to my computer. As you can see, a diagnostic message is printed if a previously processed image or link is encountered again during the recursive crawl. Likewise, a diagnostic message is printed if the maximum depth limit is exceeded during the traversal of the link graph. And it also does other things to make sure we don't get duplicates counted. And the final result is that there's a number of 21 total images that are reachable from this page. Just for kicks, let's go ahead and use a web-based way of doing this. So to figure out what that is, we go over here to the utils directory and look at options. You come down here, you can see that we've got options, and one of the options is the -W option, which says do the crawling remotely on the web. So let's go ahead and add that -W. And now let's rerun the program. And this time you can see that it's actually going out to the internet and it's checking links at my website rather than doing things locally. And they're giving the results back that we would expect. And once again, we get 21 total images that are reachable from that particular point. So that's the end of that case study. Hopefully you have a better idea of how to use Java object-oriented features in order to do an interesting program that traverses recursively structured folders, either locally or in the web, and counting the number of elements it finds along the way. It is not hard at all to generalize this to do other things besides count images if you want to do other kinds of web crawlers.